So let's, why clean code matters. So as developers, we might think, okay, I just want to write my code and just get it over with. Yes, but it is actually very important to uh, pay attention to certain things while writing our code and while working on a code base. So clean code is used to describe um, a code that is easy to read, understand, and maintain. So if your code is written in a way that is simple, concise, and expressive, it is easier to maintain that particular code base, and it's easier for other developers to take over the project, and they'll be able to understand the existing code base and build upon whatever it is you've worked with. And even for yourself, because sometimes you can write a code today, visit it in 2 weeks' time, and you'll be lost that, oh, what did I do here? What does this do? What does this function do? But if your code is clean and concise, it's going to be easier for you to pick up where you left off. And yeah, so clean code is easy to read, understand, and maintain, and it is essential for teamwork and long-term projects. And poorly written code can lead to bugs, wasted time, and frustration, obviously. So when a code base is not is very complex, it can lead to decrease in productivity, because you'd spend more time trying to understand the code, trying to read through the code and understand, than a code that is very clean, whereby you spend less time trying to go over the code and more time doing what you actually need to do on the code. So yeah, so yeah, this is a quote by I said a quote, sorry. This is a quote by John Woods that says, always code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. So you can imagine, if the person that is going to take over um, your code is a psychopath, you can imagine what that person is going to do to you. If your code base is not is very complex and not easy to understand. So we have some principles that can guide you while writing code. So we have dry, do not repeat yourself, and this principle is to avoid duplication by reusing your code. And we have the KISS principle also, keep it simple, stupid. Simplicity is key for this principle. It just refers to simplicity, to avoid unnecessary complexity in your code. Then we have the solid principles, and the solid principle is a set of 5 principles for object-oriented programming. So we're going to take the different principles one at a time. So for the dry principle, it says every piece of knowledge must have a single unambiguous representation within a code base. Sorry. So the dry principle reduce the advantages of dry principle. It's that it reduces redundancy, and it makes maintainability easier, and it minimizes error. So basically, this principle helps to avoid repetition and repetition of the same information in your code. So sometimes not even sometimes, having the same information multiple times in your code makes it difficult to maintain. And sometimes this can lead to some bugs. So yeah, so this principle is just about you not repeating yourself in your code. So for every piece of knowledge, for every piece of knowledge in your code, it must have like a single representation within your code base. And yeah, So this is an example of a code. One isn't following the dry principle, do not repeat yourself, and the other one follows it. So basically in the first one, you can see that we have two functions that calculate the area of different shapes. Yeah. So instead of repeating yourself multiple times, for example, now if you want to calculate the area of, let's say, like 5 different shapes, you have to write that function over and over and over, like in 5 different places. So the do not repeat yourself principle basically says, okay, just have this in one place and you can reuse that function. You can reuse that function like has you need it. So that is for the do not repeat yourself principle. So then next we have the KISS principle. For the KISS principle, it's saying you have to keep your code simple and straightforward. And because it says your code should be simple and straightforward, does not imply that does not imply stupidity. So you still have to do it with you still have to do it the right way in order to align with the goal you want to achieve in mind, but you still have to like keep it simple and not too complex. So yeah, so complex code is hard to understand, debug, and maintain. That is the use of the KISS principle. So here we have a sample code also. One follows the simplicity principle and the other doesn't. So as we can see, obviously, if you are going through a code base, you would prefer to see the second one, the clean version, rather than the version that doesn't follow the KISS principle. So it is so basically simplicity is just key in your code. It is key because it saves a lot of time and frustration. Yeah. So for the last principle, we have the solid principle. So for the solid principle, it is a collection of 5 design principles for objects-oriented programming. And when implemented correctly, it can help developers create code that is easy to read, understand, and maintain. So the solid principle, I think it's self-explanatory what they do. So let's move to the individual principles. So for the first one, the S, we have the single responsibility principle, the SRP. This says a class should have one and only one reason to change. And the other one for the O, open close principle, the OCP, says classes should be open for extension, but closed for modification. The third one, Liskov substitution principle, LSP. It says subclasses must be substitutable for their base classes. And for interface segregation principle, ISP, set classes that implement interfaces should not be forced to implement methods that they do not use. Then the dependency inversion principle, high-level modules should not depend on low-level modules. Both should depend on abstractions. Abstraction should also not depend on details. Details should depend on abstraction. So these 5 principles, they help us understand the need for certain design patterns in software systems. So so the single responsibility principle, like as I mentioned earlier, it says a class should do just one thing. So it says a class should do just one thing, and it should have only uh, one reason to change. So classes with a single well-defined responsibility are easier to understand and modify. So imagine a class that has different logic in it and a class that has just one single logic in it. It's way easier for you to understand and modify it when the need arises to modify it. So so unit tests are easier to write for classes with a single responsibility. So when classes have just one focus, one responsibility, it is easier for you to write unit tests for those classes. And modification to one responsibility doesn't affect unrelated parts of the system. Since these classes have only one responsibility, an update and change to this won't affect other unrelated parts of your system. But imagine that the class has different responsibility, 2, 3, 4. It becomes difficult to maintain. So um, so here we have a sample code that doesn't follow the SRP. So if you look at this sample code, you'd see that has the class has different responsibilities. The first is to validate an order. The second is to save to the database. The third is to send an email. So as you can see, this class is just jam-packed with different responsibilities, and it's not meant to be so because of maintenance and simplicity. So so here we have a modified code that follows the single responsibility principle. So if you look closely, you see that the responsibility has been shared to different classes. We have a class that validates, we have a class that saves into the database, we have a class that sends out the email. So the responsibility has been separated at this point. So here, if you look at it, you'd see that this code would be, you'd be you'd understand this code better than the previous one, which I just showed. So this is what single responsibility um, principle is talking about. So the the next one is the open closed principle. So the open closed principle basically is, it says that classes should be open for extension and closed for modification. So you can extend a particular class, but that class should be closed for modification. So this is a principle that is also important to put in mind when writing your code. So the advantages of this principle is that features can be added without modifying an existing code. And the risk of breaking existing functionality when making changes is reduced significantly. So since you have no reason to modify a code that is already existing, so the risk of breaking that existing functionality is like it's reduced by following the open closed principle. So so here we have a sample code that doesn't follow the open closed principle. So we have a sample code that doesn't follow the open close principle. So if you look closely, you would see that for this function, it's the way the function is open to modification. When you want to add a feature, you have to modify this existing code to be able to add a certain feature to this code. So here is a code that follows the open close principle. So as you can see, an interface has been created for order type since we have different order types here. namely the online and offline order. So we have an interface here, and the interface is implemented by the different classes. So if you have any other order type, all you have to do is just to extend that particular code by implementing the interface. You do not need to come and start modifying the existing code and risk breaking an existing functionality. So for the next one is the Liskov substitution principle. For the Liskov substitution principle, it says that subclasses should be substitutable for their base classes. So this enables the use of polymorphic behavior, making your code more flexible and reusable. And it ensures that subclasses comply with the rules and structure established by the superclass. So this basically means that when you have a class B, and that class B is a subclass of the superclass A, you should be able to pass an object of that class B to any method that expects an object of the class A, and nothing weird should happen. The code should still function the way it's supposed to function. That is what the Liskov substitution principle is talking about. So if you look at the code sample here, we have a class bird. So in the next class, we have a class penguin. We know that penguins do not fly, but here the class penguin is trying to extend the class bird. And obviously, that is going to put out some weird outputs because penguin cannot fly. So here we have an updated code that follows the Liskov substitution principle. So we have a class bird. It has a common logic. That is the common logic for all birds. Then we have a class flying bird. So this particular class is for birds that fly. So you can extend, so this flying bird can extend the class bird, which is a common logic for all birds. Then we have a class penguin that can also at the same time extend the class bird because they have a shared logic, right? And no weird outputs would happen here because this follows the Liskov substitution principle, right? So moving on, we have the interface segregation principle. So the interface segregation principle states that classes should not be forced to depend on interfaces that they do not use. So this reduces class dependencies. It enhances modularity and maintainability, and it minimizes unnecessary dependencies, ensuring clients only rely on relevant method. So basically, this is trying to say, okay, class-specific interfaces, they are better than a general purpose one. So a class should not be forced to depend on interface that they do not use. So let's look at this code example here. For this example here, you see that this code here violates ISP. We have an interface, other actions, and these other actions has different properties within it. That's the process, the cancel, and the refund. Then we have a class that is trying to implement this order action interface. You'd see that the online order, it uses the process, the cancel, and the refund. But because the refund does not apply to the online order class, it throws an exception. So here is an updated code that follows the ISP principle. So we have different interface for the different process, the processable, the cancelable, and the refundable interface. And this interface can be implemented as necessary. So looking at the online order class here, it implements only the only the interface that it needs. That is the processable and the cancelable, and not the refundable. And everything works fine here. So the last one of the solid principle is the dependency inversion principle. The dependency inversion principle states that it said that classes should depend on abstraction, and instead of concrete classes and functions. So depend on abstraction, not concretions. So right here, so instead of depending on separate logic and so it's best to just depend on the different abstractions. So this promotes flexibility, maintainability, and scalability by reducing dependency between modules. And this makes code easier to understand and modify. So here is an example. We have an order processor. So here we have a constructor trying to instantiate in a database object here. So we also have a process order method here also. So now looking here now, we, instead of trying to construct the new database objects every time, we have the interface, an interface here, the database interface here, that which can be implemented as necessary. So yeah, so instead of depending on this particular method here, you'd rather depend on an abstraction, which is the interface here. So yeah, so in conclusion, writing clean and maintainable code is essential for teamwork and long-term projects, and also for professional growth, because employers and peers also, they look at your code, they see you in your code. Yeah, I think that's right. They see you in your code. If your code is looking shabby and not clean, it's not, I don't know, it's not good for your professional growth, and it would be very difficult for you to scale that way. But if your code follows the right standards, the principle, and you let this principle guide you when you're writing your code, it's actually good, because it makes you grow, personal growth, and also it brands you in a very good kind of way. Then principles like dry keys and solid provide a framework for creating high quality software. And while these principles have immense benefits, they also come with trade-offs, such as increased complexity or over abstraction. So these are also cons that you have to put in mind while you are trying to implement these principles, so as not to overdo. So start applying these principles in your project, even in small steps. And remember, clean code is not about perfection, but about continuous improvement. So and funny enough, I'm sure many developers, even if you've not heard about any of these principles before, or if you've not been consciously following, if you don't know like each word for word, each principle, what it means, I'm sure many of us are following this principle, but we just do not know. So if we add the knowledge of this principle to what we already have existing, I'm sure that we are going to write great codes. So then we have a quote here that says, clean code is not just a set of rules, it's a mindset. It's about caring for the craft of software development and the people who will work with your code in the future. So, so thank you everyone for listening. I would be open to take questions if there are any questions for me. Thank you.
All right. Thank you, Hadiza, for this presentation. Can you hear me, please?
Yes, I can hear you.
All right. I think I've learned a lot this morning. I've learned a lot from your presentation. Well, you know, I've always been maintaining design pattern. I hope you know design patterns, right? And then some of this principle actually appears in design pattern. I really don't know how to connect this with design pattern, basically. All right. So the question is, how do we connect all these principles, the key, solid, and all that with design principle, so that
Um,
while you are maintaining one design principle, you are following the design patterns, you are following the design principle, you are following the principle mentioned.
so if I should get your question right, what you're trying to say is how does this clean code principles connect with design patterns,
Yes,
right?
exactly.
Um, I feel like in this they connect in the sense that everyone hear me?
Yeah, I can hear you now.
Okay, sorry, my inverter went off, so my internet went off also. I had to connect to my phone hotspot. So I said, sorry, what was I even? Okay, we're talking about design patterns and the principles.
Yes.
So I feel like, in my own opinion, when it comes to design patterns and how they connect to this principle, it just has to do with the same readability we've been talking about, something that is easy to read, something that is self-explanatory, not too complex, and also the ability to be able to reuse these different patterns. It has to do with, I think it has to relate the ability to be able to reuse this different pattern. It has to do with the do not repeat yourself. When you when you you don't have to repeat yourself several times, you just have to um reuse wherever necessary, right? And also for um for maintainability. So when you want to update, when you want to scale, it also has to, I think it relates, this principle also help in that way too. So readability, simple patterns are easy to that self-explanatory, and yeah, so I feel
Reusable.
they connect in these ways, and I'm sure they connect in many other ways too that I perhaps do not know. So
Okay. I think that's fair enough. Thank you.
Okay, I think someone said in the chat that design pattern brings about those principles. Yeah, I think that makes sense because because the design patterns they have to be reusable. They have to be reusable because most of the time they are solutions to common software problems. So so thank you, Mr. Samuel, for the question, and thank you, Ibrahim, for your contribution. So do we have any other question from anyone, from anybody else? Victoria, I can't hear you. Can anybody else hear Victoria? I think you're trying to speak. Okay, while Victoria is trying to fix her mic issues, I have some questions, and I'll be glad if we have individuals that can help us shed more light. So so how can one balance simplicity with handling complex software requirements? Do we have anyone that can help with this question? So how can one balance simplicity with handling complex software requirements? So we talked about keeping it simple. So I think this question has to do with that. So do we have anyone? Mr. Samuel, Mr. Ibrahim, or any other person?
Yeah, by following those design principles you listed, basically is what you need to actually make the complex a little bit easier.
Yeah, thank you. Thank you, Mr. Samuel. So yeah, so in addition to what Mr. Samuel said, so by using abstractions, basically, would be able to we'll be able to break down that complexity and make it simple. So, so yeah. Victoria, we still can't hear you. Okay, thank you, Ibrahim. So ensure single responsibility, one of solid principle, yeah. So you just need to break down the different complexity and into single responsibility. Okay, Victoria, you can just say something in the chat so we know, because I'm done here. I don't know if you have any other thing to add. I would have loved your inputs, but you can't seem to get across to us. All right. Thank you everyone for listening in. Thank you very much. Do have a nice day, everyone. Thank you.